This walkway held less than a third of the weight it was required to. Nobody who danced beneath it that night knew that. Neither did most of the engineers who reviewed it. Somewhere in a drafting room, 2 years before the collapse, a single line on a drawing was changed. Nobody recalculated what that change actually meant. By the end of this file, you'll know exactly which shop drawing changed one detail and exactly how much margin that one change erased. When it opened in 1980, this was the tallest building in Missouri. Its lobby was the whole point, a soaring open atrium built to impress. 3 suspended walkways crossed that lobby, each about 120 feet long, wider than most 2-lane roads, hanging from steel rods bolted to the roof. The 4th floor walkway hung directly above the 2nd floor one. Anyone standing under both at the wrong moment would be under twice the structure. Each walkway hung from steel rods threaded through box beams, held by a nut and washer at every connection. That's the entire joint holding tons of concrete and glass in the air. You probably remember this as the hotel where a crowd was too heavy for a walkway. It wasn't overloaded. The connection was never capable of holding a normal one. By the time this was over, 65 tons of steel, concrete, and glass had come down into that lobby. Rescue crews worked through the night. A severed water main was flooding the same floor they were searching. The National Bureau of Standards was brought in to determine precisely what failed. This is the report this entire file is built on. Source: the most probable cause of the collapse was the inadequate load capacity of the box beam to hanger rod connections. Inadequate load capacity doesn't mean sudden failure under an unusual crowd. It means this file goes back to construction, 3 years before the dance floor ever filled up. Ground broke on this hotel in March of 1978. The structural firm on record was a respected one. The steel fabricator was a separate company entirely, and that separation matters more than it sounds. The engineering firm designed it. The fabricator built the shop drawings, translating that design into steel. Somewhere along that thin line, the design changed. For a full year, thousands of guests walked beneath and across these walkways. Nothing about the connection changed. It had simply never yet been tested by the right crowd. This exact revision was stamped and filed 2 years before the collapse. Not hidden, filed. We'll get to the drawing that proves it. Here's the original plan. 1 rod running from the roof straight through the 4th floor walkway all the way down to the 2nd floor walkway. 1 connection point per walkway on that rod. Threading a nut down the entire length of that rod in the field was slow and difficult. The fabricator wanted an easier way to build it. So the design changed. 2 shorter rods instead of 1. 1 from the ceiling to the 4th floor walkway. A second separate rod from that walkway down to the 2nd floor one. In the original design, the 4th floor connection only had to hold its own walkway's weight. In the new design, it had to hold both walkways' weight at the same point. That one shop drawing change doubled the load on the 4th floor connection. Nobody recalculated the beam for that new number. The revised shop drawings came back stamped as reviewed. Review, in this case, did not mean a full structural recalculation. Here's the part that gets missed. Even the original single rod design didn't fully meet Kansas City's minimum load requirement. It was already thin. The change made it far worse. By the time the change was built, that connection could hold roughly 30% of what the code required. Not overloaded by an unusual crowd. Undersized from the day it was built. October 1979, more than a year before the tea dance, a section of this same atrium roof gave way during construction. Nobody was on it. It came down anyway. 2,700 square feet of atrium roof came down because one connection failed. It was investigated as an isolated incident. Construction continued. Here's what was actually happening at that connection. The washer wasn't failing. The steel around it was, slowly bending outward until the washer had nothing left to grip. Once the beam deformed enough, the washer pulled straight through the steel. That's not a bolt loosening. That's the material itself giving way. This exact set of shop drawings sat in a filing cabinet for 2 years, stamped and approved, indistinguishable from every other approved drawing on that shelf. Exactly how much responsibility belonged to which party was argued for years afterward, in hearings, in license reviews, in court. That argument never fully settled. For a full year, this looked like any other hotel lobby. That's the part that should sit with you. It never looked wrong. Every Friday, this lobby hosted a tea dance. Live music, dancing, drinks. It had become one of the most popular nights in Kansas City. On July 17th, 1981, more than 1,600 people filled that lobby for the tea dance. Dozens more stood on the walkways above for the view. The federal investigators' own conclusion? This traces to a breakdown in communication between parties, not a single reckless decision. That's the part that should worry you. Source: the load capacity of the connections was substantially below that required. A hard-to-build detail, a quiet redesign, a doubled load, a beam that was never rechecked. Every step alone was survivable. Together, they weren't. Engineers had a name for this failure mode before 1981, an unreviewed field change altering a load path. It wasn't new, it was familiar and still underestimated. The engineer of record later said he'd assigned on-site supervision to an associate. That associate was not, at the time, a licensed member of the profession's own engineering society. For a year, foot traffic and routine maintenance crossed those walkways constantly. Every day it held was treated as proof it always would. That's the quiet reframe underneath this whole file. A year without failure isn't the same as a structure with nothing wrong. A field change to save an hour of threading. A doubled load. A beam that deformed slowly, then all at once. That's the mechanism, beginning to end. You now know how it failed. What's left is why. A year-old warning sign and a 2-year-old drawing both sat unread until the night they mattered. To understand the decision trail, we go back to the exact month that drawing changed and the exact reasoning that led it through. A shop drawing revision from 1979 and a federal report from 1982, 3 years apart, are about to describe the exact same connection. If you'd been in that drafting room in early 1979, you wouldn't have seen a crisis. Just a fabricator asking for an easier way to build something. The fabricator's request was specific. Threading one continuous rod through 2 walkways in the field was slow and error-prone. They proposed 2 shorter rods instead. On paper, it looked like a fabrication convenience, not a structural change. That framing is exactly why it didn't get treated as one. The engineering firm reviewed the revised drawing and stamped it. Their later account, that review focused on general conformance with the design concept, not a full recalculation of the new load path. February 1979. A shop drawing changes one detail and gets stamped. July 17, 1981, that exact connection is asked to hold twice its intended load, under a crowd of 1,600 people. Source: the connection had a load capacity substantially below that required by the applicable codes. Sit with that for a second. Then we'll keep reading the file. Years later, the State Licensing Board found gross negligence in the engineering review and revoked the licenses of the engineer of record and his firm. None of this was hidden. The revised drawing existed in the project file the entire time. The failure wasn't concealment. It was a review that never actually recalculated the new load. The engineering profession's own society later changed its policy. Structural engineers, it said, bear full accountability for design integrity. They cannot rely on a contractor's shop drawings without personally verifying them. You've probably stood under a suspended structure, a walkway, a canopy, an atrium, without ever wondering who checked the shop drawings behind it. This is the same shape as almost every failure in this file series. Not a secret, a documented change, filed and never fully rechecked until it moved. 7:05 in the evening, 1,600 people below. A connection built to hold 30% of what it needed. That's the moment this file has been building toward, and where we stop the recreation. The deformed beam and the unrecalculated drawing aren't 2 stories. They're one mechanism, a system that only reacts once something physically gives way. To be fair to the record, shop drawing review practices across the profession changed permanently after this, and so far have held. Settlements and damages from this collapse totaled roughly $140 million. A full structural recalculation of one shop drawing change would have cost a fraction of that. All 3 documents sit in the same file now. They always could have. Every structural change you'll never see has a version of this decision sitting behind it. Recalculate fully, or just check that it looks about right. 1 rod split into 2. A stamp without a recalculation. A load quietly doubled. A beam that held for a year, then didn't. That's the file, from first drawing to final stamp. The atrium was rebuilt. People still cross it every day. Underneath the new steel, the file stays open. Reviewed for general conformance. Somewhere, a modern piece of software would have caught this in about 4 seconds. The investigation is closed. Filed, final, stamped. The pattern it describes was never unique to this one connection. The same 3 ingredients, a practical field request, a review that trusted the paperwork,
and a load path nobody rechecked exist in project files right now. The hotel still operates. The atrium still gathers crowds. The next question is, what actually changed and what didn't?
The engineering profession did change its own rules after this, not just at this one firm. The new standard: the engineer of record cannot delegate away responsibility for a shop drawing change. If the load path changes, the calculation has to change with it. Personally verified, not assumed. Every state licensing board that governs structural engineers now traces some part of its shop drawing review requirements back to this exact case. You don't need to know which building near you had a shop drawing change. You just need to know that "it's held for a year" isn't the same sentence as "it was checked." The federal investigator's final recommendation wasn't about this hotel specifically. It was about how every shop drawing review should work. Source: design professionals should maintain effective control over the review of shop drawings for critical structural connections. Here's what you keep from this file. A load path isn't a suggestion. Move where the weight travels, and every connection along that path is now carrying something it was never checked against. Next time you're under a suspended walkway or a hanging canopy, that phrase, load path, will mean something it didn't an hour ago. Nobody can tell you which unrelated shop drawing revision, filed this year in some ordinary project, is its own version of this file. That question stays open on purpose. That restraint is the most honest thing in the whole document. This channel exists to read files like this one before the connection gives way, not after. Somewhere right now, a shop drawing almost exactly like this one is being stamped, reviewed for general conformance, and filed. That's the file. A closed investigation, not a closed risk. This one is filed. The next one hasn't been read yet.